In this lesson we will solve some problems. So the problem that we have to solve here is, without actually performing the long division, you should be able to say whether the given rational number, which is in the form of p by q, has a terminating or a non-terminating decimal expansion. So let's try to solve the first example. So the rational number that you have been given is 13 by 3125. So without performing actual long division, how will you solve this problem? So if you go back to the theorems that we have learned, we should be able to factorize the denominator of the given rational number, and if that is in the form of 2 power m times 5 power n, then we can say that that rational number has a terminating decimal expansion. If it is not in the form of 2 power m times 5 power n, then it is a rational number with a repeating non-terminating decimal. So let's try to first factorize 3125. So 3125 is nothing but 5 power 5. So the denominator can be expressed as 5 power 5. And you can observe the denominator is in the form of 2 power 0 times 5 power 5, which is in the form of 2 power m times 5 power n. So we can say that based on our theorem that this rational number has a terminating decimal expansion. So if you are asked to calculate what that terminating decimal expansion is, so the next step in the process is to make sure that the denominator has equal powers of 5 and 2, so that the math gets easier. Because when you have equal powers of 5 and 2, let's say 5 power m times 2 power m, then you can say it is 10 power m. And division by 10 or powers of 10 is easy. So the next step is to have the denominator in the form of 2 power m times 5 power m. So we multiply the denominator and the numerator with 2 power 5. So now this is nothing but 13 times 2 power 5 is 32 by 2 power 5 times 5 power 5 is 10 power 5. So if you do the math, 13 times 32 is 13 2s are 26, 13 3s are 39, and plus 2, so which is 41. So 416 by 10 power 5, which is 5 zeros. So this would become a 0.00416. So this is the decimal expansion of the given rational number 13 by 3125. So the next problem that we will solve is 6 by 15. So we have been given this rational number 6 by 15, which is in the form of p by q. Now we have to find out if the decimal expansion of this rational number is a terminating decimal or a non-terminating repeating decimal. So before we apply our theorems, we need to make sure that in this p by q notation, p and q are coprimes. Here if you observe, 6 can be factorized as 3 times 2 and 15 can be factorized as 3 times 5. So they have a common factor 3. So we need to make sure that the common factor is cancelled out and we will be left with 2 by 5. So now we observe the denominator is in the form of 2 power 0 times 5 power 1. So this is a rational number in p by q notation having a denominator in the form of 2 power m times 5 power n, where m is 0 and n is 1. So this is a rational number with a terminating decimal expansion. And if you are asked to solve for that decimal expansion, you can easily do the division here. 5 divides 2 0.4 times, or you can, in order to be consistent, you can apply the same technique that we have applied in the previous example, where we multiply the numerator and denominator in such a way that the denominator will have equal powers of 5 and 2. Because when it has an equal powers of 5 and 2, then we can express it in the powers of 10, which makes the division easy. So here we have a denominator with a power of 5 which is equal to 1. So multiply the numerator and denominator with the same power of 2. So here we multiply the numerator and denominator with 2 power 1. So this is nothing but 4 by 10, which is equal to 0.4. So this is the terminating decimal expansion of the given p by q rational number. So the next example that we will solve is 31 by 343. So let's try to first express both numerator and denominator as product of primes. So 31 is a prime number by itself. So the only factorization of 31 is 1 times 31. Whereas 343, let's factorize that. 343 when divided by 7 will result in 49, and similarly again 7 times 7. So this is nothing but 7 cube. So we have 7 cube in the denominator and there is no 7 in the numerator. So 31 and 343 are co-primes by nature, and the factorization of the denominator is 7 cube, which is not in the form of 2 power m times 5 power n. So we can state that this number 31 by 343, which is in the form of p by q, has a non-terminating repeating decimal based on the theorem. So now let's look at a final example. Here we have been given 77 by 210. So the first step is to factorize the numerator in the product of primes. 77 is nothing but 7 times 11. And 210, let's see the factorization. 2 105 times, 3 35 times, and 5 7 times. So the denominator is 2 times 3 times 5 times 7. And as we observe, there is a common prime in both numerator and denominator. So let's cancel that out. So now the numerator and denominator do not have any primes which are common. So these two numbers are co-primes. So now if you observe, the denominator is in the form of 2 power m times 5 power n times 3 power p. But this is not in the form of 2 power m times 5 power n alone. There is an extra 3 power p over here where m is 1, n is 1 and p is 1. So this number is a non-terminating repeating decimal, because based on the theorem the denominator cannot be expressed in the form of 2 power m times 5 power n. So in this way we can apply the theorems that you have learned in the rational numbers lesson and prove whether the given rational numbers have a decimal expansion that is terminating or non-terminating recurring decimal.